Okay, so we're going to start looking at pyramids and cones today. And let's start with a pyramid. So a pyramid, we're just going to do what we refer to as square pyramids. And so it is um, a polygon base, a regular polygon base is the ones we're going to be looking at, with congruent lateral sides that are triangles. And so because they are triangles, they must all meet at a single point. So the most basic kind of pyramid that we talk about is a square pyramid. That is, a base is a square. And so it looks like this, where you've got this square on the bottom, and then you have these four triangles around the side. The four triangles are going to be congruent to each other. They don't have to be equilateral triangles, though they can be equilateral triangles. So in this case, for this particular one, we're going to name a few things. First off, we obviously have our base, and so that's the square here on the bottom. And then there are three others that we have to worry ourselves with. The first is what we're going to call a lateral edge, and we use that term. The edge is an actual, it's like the crease that you can feel on the side of a book or on any kind of shape where there's actually two things that come together to create an edge. That's going to be what an edge is. And then we're going to have the altitude, or the height. And the height, this is the hardest one to see. It starts from the vertex point, the point that the triangles all meet at, and goes to the center of the base. And so that is going to be referred to as the altitude of the pyramid. And so that's hardest to draw because you've got to go to this kind of imaginary point that is the center of the base. And then the last one that we're going to worry ourselves with is going to be what's called the slant height. Okay, and the slant height goes from the vertex point to the midpoint of one of the sides. And what it turns out to be, the slant height is the height of one of the triangles. Okay, and you've got these four triangles that are congruent to each other. Thus, each of them are going to have the same height. So when we look at this and we talk about the surface area of a pyramid, and so that's our theorem 10.3, where we can think about it very similar to how we thought about the surface area of and then this is also lateral area, but that we did a prism, in that you got these triangles, and all of those triangles are going to have the area of 1/2 base times height. Now, one thing is we will use h to represent altitude, and then for slant height we can't use h, and so instead we use a cursive lowercase l to represent slant height. To do lateral edge, we usually do L dot E dot, lateral edge. And so each of these triangles has an area that is this side, the length of one side of the base, times 1/2 times the height, the slant height, which is L. So if we do all of them, then we get that base 4 times. Well, 4 times the base just turns out to be the perimeter. And so we can say that the lateral area is equal to 1/2, and instead of base times L, because the base, that's just one of the triangles. If we want all the triangles, it's just the perimeter of the base times L, which is the slant height. And so remember, P is going to be the perimeter equal the perimeter of the base, and L the slant height. And so that means the surface area, which is every part of it, which means you're going to do the lateral area plus the base, is just going to be base plus 1/2 PL. Area of the base plus 1/2 PL. And the base can be anything that we know how to find the area of, including regular polygons. It might be a pentagon base or a hexagon base or a nonagon base or a 40-sided base. Whatever it is, if it's a regular polygon, all of this is going to work just fine. So a couple of quick examples of this. For both of these, find the surface area. And so for this one, we're going to have a square. And what's going to happen on this square is we're going to know that the base has side length 8, and then the lateral edge is going to be 6. And you want to find the surface area of this square pyramid. Well, when you do this, use your formula. It's going to be the area of the base plus 1/2 PL. So we need to know the area of the base. Well, that's something we know right off the bat because you've got 8 times 8 is 64. We know the perimeter, right? The perimeter of this base, it's a square. And so it's just 4 times one side. So 4 times 8 is 32. Now, what we don't know is the L because you're not given the lateral height. You're given the lateral edge. So to find the lateral height, we need to find that length. Well, we're going to have to use Pythagorean theorem. If the lateral edge is 6 and the base is 8, that means this is 4. And so to find L, we're going to need to do L squared plus, and then this is 4 because it's half the length of the base because the lateral height always comes to the midpoint of the sides. So plus 16 equals 36. So that gives me L squared equals 20, or L equals 2 square root of 5 when you take the square root of both sides. So now I can put in 2 square root of 5 here, and I get 64 plus, well, the 1/2 times 2 cancels out, 32 root 5. And so the surface area of that square pyramid is 64 plus 32 root 5. Another one, for this one, find the surface area. And this one, we're going to have a regular hexagon base. And your base is going to be length 4, and your lateral height is going to be 5. And so to find the area, the surface area is going to be the area of the base. Well, you're going to need to remember, how do I find the area of the regular hexagon? If you remember the formula is 3 side squared root 3 over 2. If you didn't remember that, then you're going to have to come up with another way to find it, but you should be able to do that. So that's the area of the base plus 1/2 the perimeter of the base, which is just 24, times the slant height, which I gave you as 5. And so it turns out that is no problem to be able to go through and calculate if you know those formulas. And so you just end up with 24 root 3 plus 60 is the surface area of that pyramid. The second thing we're going to do is a cone. And so a cone has a circle base with lateral area that meets at a point or a vertex. It looks like this. If you remember when I talked about a cylinder, I talked about how you can fold up a cylinder or roll up a rectangle to form a cylinder. You can kind of do the same thing with a cone, but it's not as straightforward. A cone is always found out by some section of a circle where you take out kind of a Pac-Man looking thing. And any section of a circle can be rolled up into a cone by connecting these two pieces together. So if you can kind of imagine around the center of that circle becoming the vertex, and then the base just becomes whatever the length is of that remaining. Well, it turns out that the areas are easy to find for this. The formula is really nice. And so theorem 10.4. And the lateral area is just going to be pi times the radius times L. Now, in a cone, you don't have the lateral height and the lateral edge because there is no lateral edge. So everything's just a lateral height. And so this is going to be L. Now, we do have the altitude. The altitude goes to the center, and then this is radius. And so in a cone, all you have to worry about is the radius, lateral height, and altitude. You don't have to worry about the additional lateral edge like we did in a pyramid. And so the L just turns out to be whatever this length is right here, the lateral height of your problem, which turns out in our circle, Pac-Man looking circle, is just the radius of that Pac-Man circle is the lateral edge of that problem. And then the surface area is just the lateral part, pi r L. So that's just the part that's going around, plus the base, which is just pi r squared. And so that's a pretty easy formula to use. And so you can say find the surface area of this one. Where you got radius 5 and lateral height 8. And so you just do surface area equals pi times radius, which is 5, times lateral height, which is 8, plus pi times 5 squared. Very, very straightforward. And so that just turns out to be 65 pi is the surface area of this cone. A little bit more complicated would be one like, let's say this, where you're given that the lateral height is 6, and you're given that the altitude is, let's say, 3. And so you need to go find the radius to be able to do this problem, because when you do surface area, it's pi times the radius, which I don't know, times L, which I do know is 6, plus pi times the radius squared. But all I need to do to find the radius is to find the radius to finish this. And this does turn out to be a right triangle, where you have the altitude, lateral height, and radius make a right triangle. So 3 squared plus r squared equals 6 squared. So r squared equals 27. Take the square root of both sides, and you get r equals 3 square root of 3. That actually turned out to be a 30, 60, 90 triangle. And so r is 3 root 3. So we put that in for both of these. This just turns out to be 18 pi root 3. This is going to be 27 pi. They can't be added together. So your surface area on this problem is 18 pi root 3 plus 27 pi.